Every time you press the power button on your computer, something incredible happen. Billions of the tiny electronic switches wake up. The processor start executing instruction. Memory comes alive, and within a second, an entire digital world appear. What is this entire digital world exactly? It means your computer will start. Most people are stopped there. They use the apps, they click the icons, they never ask what the underneath every app, every game, every browser, there is an operating system, and today we are going to build one. So operating system, it means having the no framework, no shortcut, no, it means we building the operating system having the no framework, no shortcut, no pre-built engine, just a raw hardware and the code. What is the operating system exactly? To understand the operating system, we will take an example of the restaurant. Imagine a busy restaurant. The hardware, it contains, the operating system contains the hardware is the kitchen, the stove, the fridge, the ingredients are the powerful but completely useless without the instructions. This hardware are the completely useless without the instruction. And another is applications are our customers, like the Chrome, Discord, another games or Spotify. They don't just care how the hardware work, they just wants the result. And kernel is our head shape. It means it is the brain of the operating system, and operating system kernel is the head shape. So shape, to understand the example how actually this work, the shape shouting a order, then kernel control everything. It decides who gets the memory, who gets the CPU time, who can access the files, and who has to wait. It means the process wait. To understand the kernel, do you need to understand without kernel application would fight each other for hardware access. One bad program could crash the entire machine. So our mission is to build the brain that control the entire computer. There are the many ways to design an operating system, and we are choosing the monolithic kernel. This is the some basic philosophy used by the monolithic systems like the Linux. To understand the monolithic kernel, initially we need to understand three most important division of the operating systems. First is the application program, or it is also known as the user space, and another is the kernel space, and most important, which is the hardware space. In kernel or the monolithic kernel, there are the most important things, which is process management, file management, drivers. These are the just example which contain in monolithic kernel. Likewise, there are the lots of things contains in this. So what is exactly contains in monolithic kernel? Like the VFS, system calls, IPC, file system, scheduler, virtual memory, device driver, then IDT. What is exactly this? VFS means virtual file system, and system call, which can call the every process, and the interrupt process control, which can interrupt the process, file system, scheduler, virtual memory, and device driver. This all of that are the part of the monolithic kernel or the kernel. So is it we are seeing in our mobile, if we take an example of a mobile operating system, we can just run the one application at a time? No, we can run so many applications at a time. So likewise, to handle the multiple application, it is the work of the kernel, or the handle the user space, it is the work of the kernel, which is the layer in between the hardware layer and the application layer. In user space, we can heard so many applications like the GVim, Xserver, SSH, GCC, Firefox, and then also the Bash. In hardware, so hardware is just our keyboard or the CPU? Not. Hardware contain CPU, memory, network interface, which can control your networking part, then storage device like your RAM, ROM, and all other devices. Okay. So kernel just depends on this. Kernel is not depends on the these programs. Kernel also having the process management, then memory management. In memory management there is a current in virtual memory, then another network stack subsystem, network device driver, and then hardware protocol layer contain PCI like our USB, character drivers, and file system driver, block device driver. Likewise, we will see in this our next episode. To understand the monolithic kernel is the super chef. Instead of the separating every responsibility into tiny worker, one massive high speed system handle everything directly. A monolithic kernel is like our super chef, which can, instead of separating every responsibility in with different worker, it can have one massive high speed system which can handle the everything directly, like keyboard, we can type some letters on keyboard, the kernel screen instantly. That means faster communication, lower overhead, and much better performance. To understand the monolithic kernel, there is the most important part, which is the 64 bit. It means a tiny rote and giant highway animation. We are also building the 64-bit processor. Old 32-bit computers were like a tiny two-lane roads. Modern 64-bit processor are a massive digital highway. They can process vastly more memory, more instruction, and more data at once. We will start simple. They evolve our operating system into a true modern 64-bit system. But how does our operating system even start? It means the part of the boot process. The starting the operating system, it is the most important part of the boot process, and there are the steps which can including the boot process. Like first step is a BIOS or UEFI. It means the moment when you press the power button, here is a power button, or this is our power button. When you press the power button, the motherboard wakes up first. Motherboard wakes up first. This is a firmware system, or called the BIOS or the UEFI. Checks if the hardware is working. It can check the hardware is working. It means it will check the it contains RAM check, CPU check, then it searches for something called the bootloader. So our step 2, it means our group 2 menu. Step 2 is our group. What is exactly group? We will use the bootloader called the group in our operating system. Think of the group as a delivery truck. Its only job is to find our kernel file and place it into a memory. And group is exactly nothing but the grand unified bootloader. It is basically a standard bootloader program used by the most of the Linux operating system. When you turn on your computer, group is the first thing that run after the system hardware is initialized. Think of the group like the delivery truck. Its only job is to find our kernel file and place it into a memory. It means when you power on, it will call the ROM code, and booting devices. It means first it will initialize the hardware part or the booting devices like the NAND gate, then USB part, etc. Then it can call the bootloader, which it will contain which it is contained in our operating system, and then it can call the kernel, and then the platform. It means our operating system, OS. We see in the group when we open the any Linux operating system like the Ubuntu, or there is a written Ubuntu. When we click the Ubuntu, it will open it. There are the like advanced options for Ubuntu, then memory test. Likewise, options are contained in a group. So the next step 3 is our handover. Handover is the handling a key animations. Then comes the most important moment when groups hand the control over to our code. Group handle to control to our code. In this diagram, we see after the group or the bootloader, there is a kernel space will be start. It is our the code which can hands the group. At exact moment, kernel takes over, which is our step 4. Kernel takes over. At that moment, our operating system become the boss of the machine, and no Windows, no Linux, just our kernel. So to build this kernel, then bootloader, so what will exactly, or the programming language which we will be using? Currently we are using the assembly language programming, which can use to talk directly to the CPU. We need to assembly language, and assembly is extremely low level. Every instruction directly control the processor. It is difficult but incredible powerful. Then another is a C language, which is a C code editor. Then we will use the C programming language to build the higher level logic. C is a fast, minimal, and close enough to hardware that operating system can trust it. But here is the catch. In operating system development, there are the no helper libraries. If we want to text on a screen, we must draw it. If we want to the memory management, we build it. If we want to the file system, we create it. Over this series, we are going to transform a blank screen into a real operating system. First, we build the foundation, which is a bootloader, then kernel, then graphics, then our first code, which is the hello world. Then we teach the OS how to think, memory management, then multitasking, then CPU scheduling. And finally, we building the actual digital world, which is our file system, command line, mouse support, Windows, and GUI like that. So building an operating system is one of the hardest challenge in our programming. You are building the software that control all other software. Assembly language, programming, ALP, and C. These are our languages. Most are the important which we are using. So you are building the software that control all the other software. It is frustrating, complicated, sometimes painful, but it teaches you how computer really work. And in this next episode, we begin the building our development environment and write the first real line of the kernel code. And open your terminal and let's build an